The diagram shows a circle with the equation x squared plus y squared is 16, with points A, B being the horizontal intercepts, as we can see, and DC is a tangent to the circle at point D, intersecting the x-axis at point C. Point D, we're told, has coordinates 2, -2, √3. Show that the equation for the tangent at point D can be written in this form. I suppose there's a few ways we could go about this. I mean, to find the gradient, we could differentiate, but I think what's possibly easier is to just think about this line here, which would be 2 across and 2 √3 down. And so the gradient for this line here, the gradient of the radius, would be -√3. So it would be -2 √3 over 2, -√3, which means that the gradient for our tangent would be 1 over √3, because the product of these has to be -1, because a radius and a tangent meet at right angles. So if we use, for example, y minus y1 is mx minus x1, you could just use y equals mx plus c. We can use, we know it goes through this point, so that will be y plus 2 √3 is equal to 1 over √3 x take away 2. So that gives me √3y plus, if we multiply this by √3, 2 times 3, which is 6, is equal to x take away 2, and then that gives me √3y is equal to x take away 8 as required. So the next thing we want to do is determine the coordinates of point C. Well, that's the x-intercept, so y would be 0. So we had √3y is equal to x minus 8. So if y is equal to 0, that gives us 0 equals x minus 8, and therefore x is equal to 8. So C is the point 8, 0. The region bounded by the arc AD, the line segment DC, and the x-axis is rotated about the x-axis. So let's have a look at that. So let's get rid of some of my drawing off of that. So the arc AD, the line segment DC, so we're talking about this region just here. So I think we'll do this in 2 sections. So we've got the arc here and the straight line here. And we're rotating around the x-axis. Now remember, D was the point 2, -2 √3. So for this section, we know that the curve there is x squared plus y squared is equal to 16. So if we're doing pi times the integral of y squared dx, what we're going to have is pi times the integral of 16 minus x squared dx from here, which is -4, across to 2. Now, as far as this is concerned, this is just going to give us a cone. We don't even need to integrate for this one. It's a cone, and we know this is 8 and this is 2. So the height of that is 6, and the radius is 2 √3. And so the volume of a cone is 1/3 pi r squared h. So that's just going to be 1/3 times pi times 2 √3 squared times 6. So the total volume is going to be pi times the integral of 16 minus x squared dx, and that's going to be evaluated from -4 to 2, and then we're going to do 1/3 times pi times the radius, which was 2√3 squared, times the height, which was 6. So we just need to evaluate this. So we can do the integral, and so that's going to be from -4 to 2 of 16 minus x squared dx, and that gives me 72. So this one is 72 pi, and then so 2√3 squared is 4 times 3, that's 12, times, well, 6 and the 3, we can cancel those to give us 2, so that's 24 pi. So altogether that's 96 pi. We're asked to give this as a decimal, so 96 times pi is 301.59 cubic units.